In section 1, we're going to talk about an overview of what is extended reality. The New Media Consortium in 2020 defined extended reality as a comprehensive term for the environments that either blend the physical with the virtual or provide fully immersive virtual experiences. Extended reality includes virtual reality, also known as VR, which is a fully artificial environment with full immersion in a virtual environment. Again, the key here is full immersion. Augmented reality, or AR, is where virtual objects are overlaid on real-world environments, the real world enhanced with digital objects. Objects, again, are overlaid on top of the real environment. So here are a couple of examples of what that looks like. In VR, or virtual reality, again, there's two types of VR. There's fully animated environments, and then there's ones that utilize a 360-degree video. So you can see the difference between both of these, that one's animated, one is actual. But when you look at both of these images, you'll see that the user is completely in another environment. They can't see the world around them while they're in a VR session. Augmented reality, on the other hand, you can see the difference here. And again, there's two different types of augmented reality. There are animated ones, so you can see here on the top with Pokemon Go, you could see the actual real background. And then you can also see that there's photorealistic types of augmented reality where on the bottom with Warby Parker, you can see glasses are being overlaid on a person's face for a more photorealistic environment. Again, the key difference with augmented reality is that we're looking at the real environment with virtual or animated or photorealistic objects being placed on top of the real environment. Now, to view extended reality content, you're going to need a head-mounted display. And this is a set of goggles, as they used to be called, that the user wears on their head and face. So there's different types of head-mounted displays. Now, some of them are self-contained devices, which means it's just the headset by itself. That includes the MedEd Quest 2, the HTC Focus, or the kind of original Google Cardboard, which gives you that stereoscopic view, one image per eyeball to give you the sense of depth in 3D. Some of the more advanced head-mounted displays, like Oculus Rift, the HTC Vive, or even the PlayStation VR, require a connected computer or console to work. So you have to keep that in mind when thinking about these head-mounted displays. Now, when you look at the prices of all these, you can see pretty wide variation, starting with free, like Google Cardboard. The smaller head-mounted display, the self-contained devices, those can run anywhere from $300 up to $1,300, depending on the platform you're looking at. Now, for the devices that require a computer console, again, a lot of variability there. Those can range anywhere from $350, like the PlayStation VR, up to $1,400. The key with each one of these, though, remember, is that you're going to need a computer or console to run it, so the cost is actually increased by the cost of that hardware. And pretty significant hardware is needed to make sure that you run these programs with pretty good speed and quality. Now, for augmented reality, these also use a head-mounted display, and you can see a couple examples here of the HoloLens, the Magic Leap, the Vuzix Blade, and the Google Glass Enterprise Edition 2, with the prices listed there. There is a pretty big price jump when you look at augmented reality, anywhere from $1,000 up to $3,500 with the HoloLens 2. These often don't require a standalone computer to operate. Now, interestingly, augmented reality can also be viewed with most smartphones or tablets, so that provides another opportunity there. Again, think about Pokemon Go. Here's an example of two images on a tablet and a phone that are being displayed on top of a real table. So let's talk about just our realities. So how do we currently train medical students, right? We utilize things like Clinical Skills Center with standardized patients or patient actors. We use cadaver labs with donated cadavers for dissection. And then we use simulation centers or high-fidelity simulations that use high-fidelity mannequins for us to do procedural and team training. Now, the biggest downside of a lot of these areas is they take a lot of resources, right? Think about the physical space involved in these areas. Think about the materials that are involved, whether it's cadavers or high-fidelity mannequins, and think about just the staff that is required to run these spaces, right? The other part is that training can only happen in these centers. You can't really have an anatomy lab and have parts that you can take home for practice and further study. Same with a simulation center. You can't take a mannequin home or do task trainers that it can be checked out to learners. So when you think about XR, it provides the opportunity to recreate these environments, but in a more mobile and digital manner. So when we think about, say, the Clinical Skills Center and the Simulation Center, we can look at things like virtual patient cases, right? You can see in this image here where it's recreating the environment of the Simulation Center using VR. And this one's going to be VR because it looks like it's fully immersive. You do not see any of the real environment around it. When we think about anatomy training, right, in our cadaver labs, we've already seen the advent and development of these, what they call 3D anatomy tables or 3D virtual tables that look like the classic dissection tables, but they pretty much serve as a large tablet, right, where people can view a dissection digitally on this device. Now, it says 3D because the objects are rendered in 3D, but they still need to be interacted with through this platform. Compare that, though, with what we call almost true virtual anatomy, and this is using, again, VR because the environment is fully immersive, and you can see how the learner can interact with the different parts of the anatomy and do the dissection in this fully immersive environment.